Hello dear students, welcome back to our CLE Degree College YouTube classes. So in today's video, we will see your physics subject. Okay, we will see the physics subject or physics class for your BSc first semester. Okay, for your BSc first semester, we will discuss the linear momentum. So that subunit, the continuation of that linear momentum. Okay, so in linear momentum, we will see the elastic collision between two particles, laboratory and center mass frame reference. So first see here, this is a 10 marks important for the SEM examination. Okay, so elastic collision between two particles, laboratory and center mass frame reference. So this is for 10 marks important for your SEM examination. Okay, in that we'll see the first elastic collision. What is the elastic collision? In previous video already we know that the elastic collision is the what? The kinetic energy is conserved and the momentum is also conserved. What? The kinetic energy is conserved and the momentum is what? Also conserved. These are called elastic collision. Got it? So elastic collision again is the kinetic energy and momentum both are the conserved. So that is known as what? Elastic collision. So see here, next we have to write down the characteristics of the what? Elastic collision. So what are the characteristics? See here, there are three characteristics. First one is the total momentum is conserved. What is the first characteristics? The total momentum is conserved, and the second, the kinetic energy is conserved. So here both conserved are there. So we have to write in terms of the characteristics. That is the what? Momentum is conserved. That is our first property. And what next? The kinetic energy is conserved. That is our second characteristics. Okay. So next here, the forces are conserved. This is our third characteristics. As well you can call it as properties. Okay, got it? So we are having here three characteristics of the what? Elastic collision. What is the first? The total momentum is conserved. Second, the kinetic energy is conserved, and the third one, the forces are also conserved. Okay, this is for the what? Explanation for the what? Elastic collision and their characteristics. We'll see next. Laboratory frame of reference. Okay, we must know the next concept related to that. That is what? Laboratory frame of reference. So see here, in that consider a two particle of mass m1 and m2. When the particle of mass m2 and be of rest and m1 moves with an initial velocity u1 in the laboratory frame. So here consider one frame is there. In laboratory frame of reference or frame of reference, our frame is nothing but what? The Cartesian coordinates, that is x, y, z. Okay, this is what our frame. So here we know what? Laboratory frame of reference. What is that? So see here, already I read the explanation. Two particles m1 and m2. So consider here two particles are there, m1 and m2. Okay, this is one particle and this is second particle which having mass m1 and m2. So next here m2 be the rest. So idenetri rest position dageti. Got it? m2 at the position of rest and m1 in the position of what? Motion. Got it? So here two particles are there, m1 and m2, their masses, and m2, the particle having the mass m2 which is at rest, and m1 is moving with an initial velocity u1. Okay, with an initial velocity u1. Understood? So this is the explanation of this diagram. So see here next. Let the particle of mass m1 collide with the particle of mass m2 at rest. Already we know that m1 is at motion and m2 at what? M2 at rest and m1 is in motion. So at that time what happened? the collision will be takes place. Already you shown one diagram. Here what? m1 is there, which having an initial velocity u1, and here m2 is there. So ಏನಾಗತ್ತೈತ್ರಿ m1 ಮೋಷನ್ದಾಗ ಐತ್ರಿ, m2 ರೆಸ್ಟ್ದಾಗ ಐತ್ರಿ. ಸೊ ಮೋಷನ್ದಾಗ ಆಗಿ ಏನಾಗ್ತೈತ್ರಿ, ಇಲ್ಲಿ ಕೊಲಿಜನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಆಗ್ತೈತ್ರಿ. ಇನ್ ಕಂಟಿನ್ಯೂ ಹೋಗ್ತೈತ್ರಿ, ಆಮೇಲೆ ಏನಾಗ್ತೈತ್ರಿ ಕೊಲಿಜನ್ ಆಗ್ತೈತ್ರಿ. ಓಕೆ, ಸೊ ಸಿ ಹಿಯರ್ moves with a velocity, let the particle of mass m1 collide with the particle of mass m2. What happened? The collision will be takes place. At rest, after the collision, the first particle moves with a velocity making an angle theta 1 with its initial direction, and second particle moves with a velocity making an angle theta 2. Okay, so ಏನಾಗ್ತೈತ್ರಿ ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿಂದ m1 ಪಾರ್ಟಿಕಲ್ ಹೋಗಿ ಸೆಕೆಂಡ್ m2 ಪಾರ್ಟಿಕಲ್ಗೆ ಏನಾಗ್ತೈತ್ರಿ ಕೊಲಿಜನ್ ಆಗ್ತೈತ್ರಿ. ಕೊಲಿಜನ್ ಆದ ಕೂಡಲೇ ಏನಾಗ್ತೈತ್ರಿ, ಇಲ್ಲಿ ಏನಾಗ್ತೈತ್ರಿ, ಇಲ್ಲಿ ಒಂದು ವೆಲಾಸಿಟಿ ಸಿಗ್ತೈತ್ರಿ, ಇಲ್ಲಿ ಒಂದು ವೆಲಾಸಿಟಿ ಸಿಗ್ತೈತ್ರಿ, v1 and v2. ಸೊ ಏನಾಗ್ತೈತ್ರಿ, ಅಗೇನ್ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ವಾಟ್ ಥೀಟಾ 1 and ಥೀಟಾ 2. ಸೊ ಇಲ್ಲಿ ಏನು ನಮ್ಗೆ 2 ಆ್ಯಂಗಲ್ ಸಿಗ್ತಾವ್ರಿ. ಅಂಡರ್ಸ್ಟುಡ್? ಸೊ ನೆಕ್ಸ್ಟ್ ಇಯರ್ ದಟ್ ಆ್ಯಂಗಲ್ theta 1 and theta 2 is called what? Scattering angle, and v1 and v2 are the velocity along the direction. Got it? We'll see next. So see, according to the principle of conservation of what? Linear momentum. Okay, next what we have to apply? We have to apply the what? Principle of conservation of linear momentum. So by applying the principle of conservation of linear momentum, we are getting what? m1 v1 cos theta 1 plus m2 v2 cos theta 2, that is equal to m1 u1. Okay, so here this is nothing but what? Our momentum. Okay, that is the for p1, that is for p2. Already we know that momentum is equal to m into v, mass into what? Velocity. So applying the law of conservation of linear momentum, we are getting this equation. So again with respect to momentum, we are taking cos theta 1 and cos theta 2. Why? So see here, because here we are getting the what? 2 scattering angle. That's why we are taking cos theta 1 and the cos theta 2. So next see here, next m1 v1 sin theta 1 plus m2 v2 sin theta 2. After simplification, we are getting what? Equation number 1. Got it? So according to the principle of conservation, we are getting this equation. Simplification, we got equation number 1. So this complete our equation 1. Next we will see. So see here, if the collision is elastic, then the total kinetic energy is also conserved. Already up to this, what we proved? We proved here the momentum is conserved and the kinetic energy is also conserved. Now we have to prove. So by the kinetic energy, they given half m1 v1 plus half m2 v2, so on up to what? Half m1 u1. Such a study of several laboratory problems for the scattering of alpha particle and Compton effect. So we are taking kinetic energy, means we have to take velocity square. Okay, got it? So if the collision is elastic, we have to prove for the conservation of the kinetic energy. So we are getting what? Equation number 2. So what is the conclusion? See here, such a study of several laboratory problems for the scattering of alpha particles and Compton effect. So ಈ type study ಎಲ್ಲಿ ಮಾಡ್ತೀರಿ ನೀವು? Compton effect ದಾಗ ಮಾಡ್ತೀರಿ and scattering of the alpha particles. Okay, next we'll move to the what? Center of mass. Okay, up to this what we proved here? We proved elastic collision and its characteristics. Next what? Frame of reference or laboratory frame of reference. Now we have to prove the what? Center of mass. So see here, already we know that what is the center of mass? The entire mass of all the particle is situated only one point. Okay, entire mass of all the particle is suppose situated in one point, that is nothing but what? Center of mass. Okay, next here, consider the center of mass at rest in the laboratory frame of reference. The velocity of center of mass VCM is given by. ನೆಕ್ಸ್ಟ್ ಏನಾಗತ್ತೈತ್ರಿ ಇಲ್ಲಿ ಒಂದು ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ರೆಸ್ಟ್ ಪೊಸಿಷನ್ದಾಗ ಐತ್ರಿ. ಸೊ ಲ್ಯಾಬ್ರೇಟರಿ ಫ್ರೇಮ್ ಆಫ್ ರೆಫರೆನ್ಸ್ ದ ವೆಲಾಸಿಟಿ ಆಫ್ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಈಸ್ ಗಿವನ್ ಬೈ. ಸೊ ಏನಿರ್ತೈತ್ರಿ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಏನೈತೆ ನೋಡ್ರಿ ಅದು ರೆಸ್ಟ್ ಪೊಸಿಷನ್ದಾಗ ಐತ್ರಿ. ಆಮೇಲೆ ಕೊಲಿಜನ್ ಆದ ಕೂಡಲೇ ಅದರ ವೆಲಾಸಿಟಿ ಏನು ಚೇಂಜ್ ಆಗ್ತೈತ್ರಿ ಅದು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗ್ತೈತ್ರಿ. ಓಕೆ, ಸೊ ದ ವೆಲಾಸಿಟಿ ಈಸ್ ಇಂಡಿಕೇಶನ್ ಬೈ VCM. So here m1 plus m2 VCM equal to m1 u1 plus 0. ಸೊ ಪ್ಲಸ್ 0 ಅಂದರೆ ಏನಾಗ್ತೈತ್ರಿ ನಾವು ಮೋಡಿಫಿಕೇಶನ್ ಮಾಡ್ಬೇಕ್ರಿ ಇಕ್ವೇಷನ್ ಆರ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡ್ಬೇಕ್ರಿ. ಸೊ 0 ಇರ್ತೈತ್ರಿ, ಈ ಟರ್ಮ್ ಈ ಸೈಡ್ ತಗೋರಿ, VCM ಆ ಸೈಡ್ ತಗೋರಿ. ನೆಕ್ಸ್ಟ್ ಏನು ಬರ್ತೈತ್ರಿ VCM equal to m1 u1 divided by m1 plus m2. So here we are getting what equation number 2. Got it? ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ದಾಗ ಏನೈತ್ರಿ ರೆಸ್ಟ್ ಪೊಸಿಷನ್ದಾಗ ಐತ್ರಿ, ವೆಲಾಸಿಟಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕ್ರಿ. ಸೊ ವಿ ಆರ್ ಫೈಂಡಿಂಗ್ ದ ವಾಟ್ velocity. So see here next. In the center of mass frame, the initial velocity before collision and after collision. Okay, center of mass already I told you center of mass is at rest. Starting ಏನೈತೈತ್ರಿ, starting it is in rest. After the particle or collision of the particle, what we are getting, the center of mass will be in what motion or rest. ಸೊ ಫಸ್ಟ್ ಏನಾಗ್ತೈತ್ರಿ ಬಿಫೋರ್ ಕೊಲಿಜನ್ ಇರ್ತೈತ್ರಿ, ಆಫ್ಟರ್ ಕೊಲಿಜನ್ ಇರ್ತೈತ್ರಿ. ರೆಸ್ಟ್ ಪೊಸಿಷನ್ದಾಗ ಇರ್ತೈತ್ರಿ, ಕೊಲಿಜನ್ ಆದ ಕೂಡಲೇ ಏನಾಗ್ತೈತ್ರಿ ಸ್ವಲ್ಪ ಮೋಷನ್ ಆಗ್ತೈತ್ರಿ, ಮೋಷನ್ ಆದ ಕೂಡಲೇ ಏನಾಗ್ತೈತ್ರಿ ಆಮೇಲೆ ಅಗೇನ್ ಇಟ್ ಗೋಸ್ ಟು ದ ರೆಸ್ಟ್ ಪೊಸಿಷನ್. ಸೊ ಸಿ ಹಿಯರ್, ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ಫಾರ್ ದ ವಾಟ್ ಬಿಫೋರ್ ಕೊಲಿಜನ್ ಆಸ್ ವೆಲ್ ಆಸ್ ದ ವಾಟ್ ಆಫ್ಟರ್ ಕೊಲಿಜನ್. ಓಕೆ, ಸೊ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಬಿಫೋರ್ ಕೊಲಿಜನ್ ವಾಟ್ u1 dash equal to u1 minus VCM, that is called as the equation number 4. And after collision what v1 dash equal to v1 minus VCM, that is v2 dash equal to what v2 minus VCM. So this is called equation number 4 and these two equations are known as what or called equation number 5. Got it? Next center of mass ದಾಗ ಏನೈತ್ರಿ ರೆಸ್ಟ್ ಪೊಸಿಷನ್ದಾಗ ಮಾಸ್ ಇರ್ತೈತ್ರಿ. ಆಮೇಲೆ ಏನಾಗ್ತೈತ್ರಿ ಟು ಪಾರ್ಟಿಕಲ್ ಕೂಡ್ರಿ ಅಂದರೆ ಕೊಲಿಜನ್ ಆಗ್ತೈತ್ರಿ, ಸ್ವಲ್ಪ ಮೋಷನ್ ಆಗಿ ಏನಾಗ್ತೈತ್ರಿ next that goes to the rest position. So after collision and before collision and after collision we are getting equation 4 and the equation 5. So next here what happened, if the center of mass frame the center of mass frame, the frame next here in the center of mass frame the center mass is always rest. The total momentum before and after collision is 0 or constant. So what is the conclusion of the center of mass here? See here in the center of mass frame. Now center of mass frame da find out madatiri. Adrage ಏನು ಇರ್ತೈತ್ರಿ the center mass is always at rest position. So rest position ದಾಗ ಇತ್ತಂದ್ರೆ ಏನಾಗ್ತೈತ್ರಿ the total momentum before collision is equal to the after collision, that is 0. So before collision and after collision that is equal to 0 or constant. So what it shows? It shows that momentum of a two particle and equal and magnitude opposite in direction. So what it shows? It's showing that which is in equal in direction, which is in opposite in direction but equal in magnitude. Got it? ಏನು ಇರ್ತೈತ್ರಿ, ಏನು ಈಕ್ವಲ್ ಇರ್ತೈತ್ರಿ, magnitude is equal and direction is opposite. Got it? So in the center of it is showing that the momentum is also conserved. So the conclusion that magnitude is equal but the direction is what? Direction is what? Opposite. So next see here also the kinetic energy is conserved. So next ಏನಾಗ್ತೈತ್ರಿ kinetic energy is also conserved. So therefore ಏನಾಗ್ತೈತ್ರಿ v2 dash equal to v1 dash and v2 dash equal to u2 dash. So that is the center of mass frame. The magnitude of velocity of particle is an elastic in collision. Got it? So up to this you have to write in your SEM examination. So this is important for 10 marks. Okay, we'll continue in next class, that is the what inelastic collision, in that center mass as well as the laboratory frame of reference. Okay, next class will continue this concept. Thank you.